Okay, hello. This is my video for today's quiz number 6, which is on chapter 16. So in this problem we had a roller. It looked like it had a shaft going through it, and the shaft was connected to some cables. And the cables, one side has a tension TA and the other side has a tension TB. And the problem wanted us to find the angular acceleration of the roller. Because the two tensions aren't the same, we know that the roller will be rotating. And so the first thing I did was just write out some of the given information from the problem. So we were given the mass, we were given the tension in A and the tension in cable B, and then we were also given the radius of gyration, which is right here. And like I said, we're trying to find alpha. And then from the picture, we know that center shaft has a diameter of 100 millimeters, which tells us that the radius converts to 0.05 meters. And so I drew this free body diagram here, showing like a cross-sectional area of this roller. And since it's suspended from each side, we can tell in the picture that there's two tensions A and two tensions of B. And so looking at this from this perspective, we had to include them, two of each tension. And then that has to equal our I alpha from the center of gravity plus MAG from our kinetic diagram. And so looking at this problem, we know we want to find alpha, and so I decided to use our moment equation from this chapter. And since I took the moment about point G, we didn't have to worry about the weight, and that means we also didn't need the cross product portion of this, because the moment is at the center of gravity, or the center of mass. And so looking at this equation, I knew that we would need this term I here, and so we know we can calculate that because we were given the radius of gyration value, k. And so we know that since we're given the radius of gyration, this is the equation that we can use to find I. And then I just plugged in our given mass and radius gyration to get our value for I. And so for this equation, we have two forces, two tensions pulling upward. One is clockwise and one is counterclockwise, and so we needed to make sure that the tension A had to be negative and tension B must be positive, using the right-hand rule. And so plugging in the forces times their distance r, which we calculated up above, gives us the moment for each one of those forces. And then that has to equal I, which we just calculated, times alpha in the k-hat direction. And so then it was just a matter of plugging in the tensions and the I value that we calculated, which is what this line is here. And then we just plug this into our calculator and solve for alpha. And we get an alpha value of 0.557 radians per second squared. And so that is it for this quiz. That's the answer. Thanks for listening.